Let's look at the quanta of the tau neutrino in the emitted boson minus, or W particle. First, let's look at the electric charge. And we can see that on the neutrino, the electric charge is 0 part. And on the boson 0, it is also 0. So the total electric charge on the tau neutrino is 0. And the boson minus is carrying away the -1 charge that was on the tau lepton. Let's look at spin. Now, the spin on the neutrino, of course, remains neutrino part is -1/2. And the spin on the boson 0 here is actually 0. So therefore, the total spin on the tau neutrino is now -1/2. Now, previously, the spin was 1/2 on the tau lepton. And so since the spin now is -1/2, we would expect the W particle to be carrying away a spin of 1. But as mentioned previously, this is compositionally founded, not mathematically founded. And we'll see that though to be consistent with its decay products, which will be anti-neutrino and an electron, the spin on the boson minus, or W particle, is 0, but the +1 spin is carried away by a boson 0. And so we can see the overall spin is consistent with the input spin. Let's look at weak charge. The weak charge on the neutrino, part of the neutrino, tau neutrino, is +1/2, as is indicated by the standard model, and it is 0 on boson 0, which makes it correct for the tau neutrino. The weak charge on the boson minus is -1, which is also consistent with the standard model. And on each of the decay products of the boson minus, the antineutrino, we have a -1/2, and the electron a -1/2, which sums to the weak charge on the boson minus. But on this boson 0, that carrying away the spin 1, we have a +1/2 weak charge being carried away, which makes the total products here consistent with the input, but inconsistent with the standard model. Of course, the isotopic spin will mirror the weak charge, and so on the neutrino we have a +1/2, and we have 0 on the boson 0, and we have -1 on the boson minus, or the W particle, for the isospin. And for the antineutrino, we have minus 1/2, and we have minus 1/2 for the electron, with another zero isotopic spin on the boson 0. Now, let's look at Rishon number. Rishon number, as stated previously, supersedes lepton number, and we'll see that for the bosons, the Rishon number is always 0, but we have a Rishon number on the antineutrino and the electron of -1 and +1, which creates a total Rishon number of 0. And color charge, of course, on the bosons we will have color charges of 0 because of color and anti-color features on this compositional parts. And for the neutrino, we have antineutrino, we have the colors yellow, blue, and red, which sum to 0. And for the electron, the colors purple, orange, and green, which sum to 0. So we can see that the quanta on the tau lepton and its decay products, for the most part, is consistent with the standard model.